Hello everyone, welcome to this tutorial on Python OOP concepts. My name is Shrutika and today I'll help you with the essential topic of Python programming. So whether you are new to object-oriented programming or looking to solidify your concepts, this session will provide you a solid foundation. Let's get started. Before we head towards the main section, let's have a look on the learning objectives. On what we are going to learn today. By the end of this tutorial, you'll understand the basic principles of OP, which is object-oriented programming. So we are going to cover up what is object-oriented programming and the concepts inside object-oriented programming in Python. So we are covering up classes and objects, then inheritance, we have encapsulation, polymorphism and abstraction. So these are the concepts in OOP and we are going to cover up all this today. Now, what is OOP? Object-oriented programming in Python is a programming prototype that uses objects and classes to structure a program. Now, if you are aware, you might be knowing Python is an object-oriented programming language. Yes? In OOP, everything is modeled as an object that interacts with other objects. Now, the main concept will focus on our encapsulation, inheritance, polymorphism and abstraction. Okay? All of which are the key of writing, you can say, organized, reusable and maintainable code. Okay? Today, I'm going to use a Google Colab. Side by side, whatever I'll be doing it inside the Google Colab. You can definitely use VS Code as well. Google Colab is an online editor and definitely if you want to go with Google Colab, you can just simultaneously code. Okay, so looking at the next concept. Now, coming to the very first, which is classes and objects. Okay, let's take a very simple scenario. Let's take a real-time example. Assuming, let's say you own a factory, okay, which is producing cars. Now, what is the very first step you do? Yes, before producing a car or whatever, what is the very first step we all do? Is to create a design. Yes, a design of a car on how it is going to look like, what its features are going to be, the functions and everything. Correct? So whatever we are designing is nothing but a blueprint. And class is nothing but a blueprint of an object. Car is an object, correct? Anything is nothing but an object. Yes? So, using a single design, we can create multiple cars, right? So that is using a simple class, we can create multiple objects. Yes? It's so simple. Okay. We'll talk about how to create a class and an object. As I mentioned, I'll be using a Google Colab. You can definitely go with VS Code as well. Okay. Whatever queries, whatever questions you have, you can put it inside the comments. My team will be answering all of them. I hope the concepts for the class and the object is clear. Okay. So class is nothing but a blueprint, okay, or a design of a particular object. Okay, and using a single design, you can create multiple objects. Okay, so using a single design of a car, we can create multiple cars. Okay, that is multiple objects. Okay, now let's learn how to create a class. Okay, so I'll show you a syntax. Okay, so the people who have not used Google Colab, let me introduce you with few things. So on the left hand side, you have few options like the table of contents and everything. Let's not go much into it. We have an option of code and text. Definitely we are here to code, so we are going to click on code and code it over here. You know there's a different cell. Then you have a run button. Yes. Okay, that's all. Let's proceed with the other with the thing. I'm going to write the class definition syntax and I'll explain it to you. I'll start with the class definition syntax and then I'll explain you one by one. So we have class. Let's start by creating a car class itself. Okay. Now, classes are created by a keyword class. Okay. And the name of the class can be anything. It can be anything. You can name it as ABC, you can name it as, you can say a vehicle or whatever. I am naming it as a car. Okay. Taking the example of a car, we'll proceed ahead so that whatever concepts are related whatever concepts we are going to cover up, you will be clear about it by just taking one example. Okay. So class car. Now I'll write a code and then I'll explain it. Now everyone might be aware like indentation is very important in Python, correct? Come on, you can code side by side with me so that you have a good hands-on. Okay, so my class is ready almost, and let's write okay, so we have a brand and a, let's make it, and then I'm gonna print the brand. So how you run this? Just click on the run button. It might take few seconds to run the very first cell. Let's break down this code. This line defines a class named car. Now a car is like a blueprint. Yeah, I already mentioned it to you, or a template for creating objects. In this case, car will be the template for creating car objects. Now, the keyword class is followed by the class name, always. Okay, the keyword class is followed by the class name, which should typically start with an uppercase. Okay, uppercase letter you can say, like car. Now, when you define a class, okay, you are defining the structure and the behavior you can say. That means the attributes and the methods. When I'm talking about structure and behavior, that means I'm talking about the attributes and methods, okay, that objects create from class we have. Okay, comes in the next part. I hope this first line is clear to you. Please try executing it side by side. You will get a very clear idea. Okay, moving towards the next is we have a special method in Python again, which is called the constructor. Okay, talking about this line. Now it is named as init. Okay, so it's double underscore init double underscore. Okay, and it is automatically called when you create a new object from the class. This init method is used to initialize the object's attributes. That means variables specific to that particular object. The first parameter, always the first parameter of any method in a class must be self. Now you might be wondering, what is this self? This refers to an object. Whatever object we will be creating using this class is referred as a self. Let's make it easy. Let's not make it more complicated. Okay, so it is nothing but a specific object you will be creating or working with using this class or a blueprint. Okay, after self, you have two additional parameters which I have added over here. One is a brand and the other one is the model. Okay, now these are the values you pass when you create a car object. Now let's say I'm adding a properties over here as in parameters. Can I say that? Please comment. Can I say that I am passing a parameters over here? I'm passing a properties over here instead of parameters. Is it a correct statement? Please write yes or no. Now I'm writing brand model. You can add it as color. You can add more parameters as well. Okay, so but right now I'm adding two. One is a brand and the other one is the model. Coming to the next, the third step, or let's say the next part, what is assigning the attributes to that object or to the object. Now inside this init method, we have self.brand and we have self.model attributes, and which are assigned to the values provided while creating the object. Okay, self.brand and self.model over here are nothing but the instance variable. That means they store the data. In this case, what we have is brand and model of the car. That is unique to each car object. Now when you create a car object, you will pass, you can say, let's say when I'm creating a new car, okay, now my entire class is ready for the car. Now using this particular design or a blueprint, I want to create my first car, or let's say an object. You can name, I'm naming it as my car. You can name again whatever, car 1, car 2, depending upon what you like. Okay, equal to, what is the name of the class again? The name of the class is car. Okay, then what are the two parameters we are passing over here? Is the brand and model. So definitely we need to mention the brand and we need to mention the model. So I am mentioning it as Kia as a brand and model as Seltos. Okay, now I want to print the brand. Okay, what I want to do is I want to print a brand. So how will I do is the name of my object dot whichever parameter I want to call. Easy? Yes? I am not making it very complicated. I am just telling you how to create a simple class. This is a syntax for creating a class. Yes? So this this double underscore init function, okay, this method, is called automatically when this object is created, and the self.brand and self.model instance variable are set to this two. Okay, and then your the last part we are doing is accessing an attribute. Okay, please try it side by side. It will give you a clear idea about how class is created over here. Okay, this is how you create a class, and using a class, this is how you create an object. Yes. Okay, now moving to the next, we have covered up classes and objects. Please mention your queries down. You can just put it inside the comment section. Okay, we'll answer all your queries. Moving to the next is the inheritance. Okay, again, what is an inheritance? So there's a definition written over here, which is it allows a class, that is a child, to inherit properties from the methods from another class, which is a parent class. Okay, let's try to understand it with a very simple example. Now, inheritance is a fundamental concept again in object-oriented programming. Once I started with this session, I showed you the learning objective, right? And inside OOP concepts, we are covering up classes and object, and the second part we are here is inheritance. Okay, inheritance again is a fundamental concept in object-oriented programming language, which will allow a new class to inherit attributes and method from an existing class, which is a parent class. Okay, let's say I have a parent class. Okay, and inside the parent class, I'll be creating a child class. Okay, now this promotes code reusability, and it will help you to maintain a clean and dry code structure. Now, what is dry? What is DRY? DRY stands for don't repeat yourself. Yes, programmers don't repeat themselves always. Yeah. Now, talking about, if you can see over here, we have a type of inheritance. So, there are 4 types of inheritance mentioned: single inheritance, hierarchical, multi-level, multi-inheritance. Okay, let's have a look one by one. And if you can see, I have a code snippet over here on the right hand side. Okay, where I have applied single inheritance. I am taking the car example and trying to apply the same thing to the example which we have taken in the beginning of the session. Let's talk about single inheritance. Now, a child class inherits from a single parent class. Example, let me give you an example. Car inherits from vehicle. Make sense? Car inherits from vehicle. Okay, so we have done with a single inheritance now. Let us move towards the next type. And the next type is multiple inheritance. Now, what is multiple inheritance? What happens exactly in it is, there is a child class. Okay, a child class inherits, you can say, from more than one parent class. Say we have a class vehicle 2, okay, or a class vehicle, okay, which could inherit from both car and bike. The other one we have over here is multi-level inheritance. Now, what is a multi-level inheritance? A class inherits from, you can say, a class that has already been inherited from another class. Now, this might be a little confusing for you to understand. Okay, so I again repeat it. It is nothing but a class which a class which inherits from a class that has already been inherited from another class. That is nothing but multi-level inheritance. Let's move to the example. Sedan inherits from car, and car inherits, you can say, from vehicle. That is an example for multi-level inheritance. Okay, so the next is hierarchical inheritance. What exactly you mean by hierarchical inheritance now? Any ideas, any guesses? What exactly this hierarchical inheritance might be? Yeah, let me explain it to you. Multiple child class which inherits from a single parent class. Okay, multiple child classes which inherit from a single parent class. Okay, example, car and bike inherit from vehicle. Okay, I hope this is clear. Okay, there's one more type which is hybrid inheritance. Okay, so it is nothing but a combination. I have not mentioned it over here, but it is a combination of more than one type of inheritance, like combining single and multiple inheritance and that kind. Okay, we are going to work, or I'll be showing you how we exactly apply inheritance. Okay, taking the example, if you can see over here, there's an example. Okay, I'll be discussing it to you. So how to apply single inheritance, we'll have a look. But talking about the rest of the inheritance, I cannot cover it up in this 1 hour of a live session because it is an extensive topics, okay, which requires a lot more detailing, you can say, for this. So what I have done is I already have a program, okay, on my academy. I will add the program link in the description. Okay, just click and continue learning. Okay, now let's see how this single inheritance is applied to the example which has been shown over here. Now, in single inheritance, what happens? Coming to the definition again, one class inherits from a single parent class. Okay, in our case over here, we have created a base class. Base class is also called as parent class. Okay, so we have a base class and it is nothing but, we have named it as vehicle, if you can see it over here. Okay, so we have a class vehicle that combines common properties. Okay, what is a common property over here right now we can see is, yes, it's a brand. Okay, and the class, the car class, okay, will inherit from the vehicle one. Okay. Now it might be a little confusing for you to understand. Okay, let's break down this so that you get a good idea how exactly the single inheritance has been applied over here. I hope everyone is with me and everyone is getting on whatever has been taught. Yes? Okay, let's break it down coming to the parent class. As I said, base class is also called as a parent class. Now, I'm only going to talk about this vehicle class. Okay. Now, the vehicle class is the parent or the base class that defines what it is going to just define the common properties and methods. Okay, that every type of vehicle should have. Okay, we have an attribute. Again, we have passed a parameter over here, which is a brand attribute. Okay, then we have a method defined, which is a start. Okay, now what the start method is going to do is it is going to simply print a generic message when the vehicle starts. Simple. Okay, there is nothing complicated in this class vehicle. Moving to the next one, we have a class car. Now again, this car class is nothing but a child class. Okay, that inherits from vehicle. Okay. In the addition of a brand attribute, what is common over here? What attribute is common between the parent and the child is the brand. Now what we are adding over here is one more attribute, which is model. Okay, because car has its own model attribute. Okay, clear? Now we have to call the parent class, okay, over here in the child. So for that, I'm going to use a super method. Okay, super dot double underscore init, and then I'm passing brand. Now what it is doing, it is used to call the parent class constructor, ensuring that the brand is ensuring that the brand attribute is initialized. In short, super method is just transferring all the properties from a parent class to the child class. Easy? Okay, then we have again is a start method. Okay, again start method is overridden to give a more specific message instead of a generic. Okay, where how it will print basically, let's say if you can see I've written self dot brand, self dot model is starting. That means if my brand is Kia, if my model is Seltos, so what you can say is how it will work. Anyone? You can just put it in the comment. So how you can say is Kia Seltos is starting. Simple. Here, okay. I just took the example which we had taken before or while creating a class. Okay. Over here, if you can see, there's another example taken. It's the same variable I've taken, and again we have a brand, okay, and a model name, okay, which is going to give me this output. Here I'm creating an object using the class car, and I'm printing the brand. I am calling what over here? I am calling the start method. Start method of the class is called over here, which gives more specific message using both brand and the model. Okay. Now you might be wondering, or there might be a question, right? Why single inheritance? Okay, let me answer that as well. So first is code reuse. That means over here, if you talk in terms of the example which we are taking, the car class inherits common functionalities, like over here in our case it is a brand, okay, from the vehicle class, reducing code duplication, that is code reuse. Correct? Then the second is extensibility. You can easily add other vehicle types, like you can add bike, you can add truck. We have already added car over here. So in the future, by inheriting vehicle class, okay, so in the future, by inheriting from vehicle without duplicating the code for brand and other shared methods. Okay. You can easily add it. I hope inheritance is clear to everyone. As I mentioned, I cannot cover up all the types in this 1 hour live session as it is very lengthy. If you want to learn more about it, definitely, I've already mentioned it to you that I have a different program on my academy, and I am putting a program link in the description, so you can just click and continue the learning. Okay, now let's talk about the next concept, which is encapsulation. Now, what is encapsulation? Encapsulation is like a protective shield, okay, that will hide the internal details of, how something works. Now, let's not stick to the definition and let's go with an example so that you get a clear idea about it. For example, when you drive a car, you don't need to know, how the engine works and everything. You just have to press the accelerator. Yes. So in programming, we can use, you can say, encapsulation to hide data and, make sure it's accessed properly. If you can see, there's an example over here I've added. Okay. So I've mentioned here like what exactly the encapsulation is, which is hiding the internal data and restricting the access. Now here, we will be talking about what is the private variable and everything. We have a class, the name of the class is bank account. In this, we have $_balance. This is nothing but a private attribute, and always a private attribute is denoted by $_. It cannot be accessed directly from outside the class. This will keep the balance secure and prevent unauthorized changes, you can say. Then we have a method which is deposit. Now the deposit method will allow money to be added to the balance. This is the only way to modify the private balance. Okay. Then we have is get balance. So this get balance method will provide a safe way to access the balance without exposing it directly. Then what is done over here is we have created an object, and the name of the object again is a account. The name of the object we have created is an account. Okay, so account is an object created with an internal balance, and the internal balance, so how it is written, account equals to bank account. Bank account again is the name of the class. Bank account, what is the name? What is the parameter we have is the balance. So what is the balance? Internal balance, we have added it as 1000 rupees. Then I want to deposit it. So if I want to deposit inside this, I'm going to call the deposit method account.deposit 500. And then to get the balance, I am calling this get balance function. I'm printing it and it gives me 1500. Clear? Now again, a question comes. Why encapsulation? Yes. First of all, it protects your data. Now what way? For example, in our case, it keeps the balance safe from direct changes. Yes. Then we have controlled. The second reason is why encapsulation is controlled access. Only specific methods like over here you can see deposit and get balance can change or access the balance. In short, encapsulation helps to keep our data safe and ensure it's only changed in the ways you allow. Okay. I hope encapsulation is clear and we can move to the next OOP concept, is nothing but polymorphism. Now what is polymorphism? Yes, the name itself, it says that polymorphism means, the word itself says that it means many forms. It allows the same method to behave differently depending on the object. Again, let's go with an example. Example, both cars and bikes can start. That is, I'm talking about a start method. Correct, if you can see. But they might do it in different ways. Yes. So, again, taking an example, for example, both cars and bikes can start. That is, if we can see, we have a start method. That means they might do it in different ways. Let's see how exactly, let's understand this snippet. So here we have created a bike class. Again, there is a method which is a start, and it is simply printed bike started. Okay. Same goes for the car. I have a car class. Again, I have defined a method which is a start method, and it is printed car started. Now this is again a polymorphism function. Let's call it as polymorphic function, which is start vehicle. Now what is happening here is this function is taking, or it takes which object is a vehicle object, and what it is calling a start method, whether it is a bike or a car. You're not specifying, but it is calling what? A start method. Okay, so whether it can be a bike or it can be a car. The next is creating objects using this polymorphism. So if you can see, I have bike equal to an object. I'm calling bike function, a bike class. Is it right? Then again, I'm doing the same. That means after that is done, what I'm writing is start vehicle bike. What it is giving you? An output, bike started. Again, for the car, it is again saying car started. The same start vehicle function works for both the bike and the car objects. Okay, calling their respective start method. Now one thing is, polymorphism allows one function. Over here, one function I'm talking about is a start vehicle function. Okay, to work with different types of objects. Now what types of objects here we have is the bike and the car. Okay, making the code flexible and reusable. Now I feel like till here whatever we have covered up, like we have covered up classes and objects, we have covered up encapsulation, inheritance and polymorphism. Okay, along with the code snippet over here, you can try executing this codes. If you have any questions, you can put it inside the comments. Okay, so I would like to mention that I have a comprehensive Python course available on Academy platform covering 70 lessons across 20 hours of content. Okay, the first 4 lessons are unlocked exclusively for Programming Hub members, for PH members. Okay, so you can start learning right away. To dive deeper into this course, and if you want to continue your Python journey, you can use my special code or discount code, which is PH subscriber, to get 25% off on this full course. Okay, so I've covered up all the main topics, you can say. See over here. Okay, so I look forward to seeing you in the program and helping you master Python. Okay, now we have done with polymorphism, we have done with inheritance, we have done with encapsulation, and now it's time for abstraction. Okay, so what is abstraction again? It is nothing but again, if you can see, there's a definition which is hiding complex implementation details and showing only the necessary parts. Okay, now abstraction is about again hiding complex details and showing only the essentials. For example, you don't need to know how to how the microwave works. You just have to set the timer and press start. Now in Python, we can create abstract class using ABC module. Okay, we'll talk about that. We can see again there is a code snippet over here on the right hand side. Now what is happening over here is the shape class is an abstract class. Okay, before using any modules in Python, we need to import it. So we are importing from ABC, import ABC and abstract method. So the shape class is an abstract class. It defines the concept of calculating the area but doesn't say how to do it. we have an abstract method. Now what is this abstract method? It means any class that inherits from shape must implement what? Area method. Okay? Little confusing? Yes, this abstract class, it means any class that inherits from shape must implement the area method. Okay? The next is the circle. What is happening over here again? Circle is the subclass of what? Shape. And it will provide a specific way to calculate the area for a circle. Okay? Now the area method, what it is doing is, it is implemented to calculate the area based on what? The radius of the circle. Okay? We create a circle object over here. If you can see, we are creating a circle object with a radius of 5. And we are using what? Area method. And we are, why we are using this area? To calculate this, correct? To print the area. So, circle dot area. What is the output we are getting is 78.5. Please try doing this, executing it, and let me know if you have any questions related to this code snippet. See, in simple terms, if you talk, abstraction ensures that every shape means in a, here we are taking circle, right? So like circle has an area method. Okay. But how the area is calculated is specific to each shape. The abstract class, which is the shape, it's nothing but it is defining the structure and the subclass circle. It provides the details for calculating the area of a circle. This approach gives flexibility while keeping the structure consistent for all shapes. Okay, so we are done with abstraction now. Let me know if you have any questions in the comments. So what we have done today is, we have seen what OOP is. We have seen the concepts inside the OOP. The concepts were class and objects, inheritance, encapsulation, polymorphism, and abstraction. All the code snippets are here, right besides. So all the code snippets are here on the right hand side of each concept. I'll just put this inside description. I'll put this PPT inside the description. You can have a look. You can take a reference so that it becomes easy for you to execute the things and understand the definitions of each of the concepts. Feel free to let me know in the comments what topic you would like me to cover in the next tutorial. Also, if you are interested in learning more, you are welcome to sign up for my Python course on my academy. I will include the link in the description below. I'm just giving you a walkthrough on whatever we have done. Thank you for watching this tutorial. If you have any queries, please put it inside the comments section below. Thank you.